Let's deploy an AI microservice on DigitalOcean using Kubernetes. I've made a few videos about this microservice now. The first video is about building it with Haystack, which is a Python library for doing RAG, Retrieval Augmented Generation, and that's a 40-minute video where I explain how the application works. Then I have two other videos on ways of deploying this on DigitalOcean, using a server and DigitalOcean's container registry. But instead of having a fixed monthly cost server in this video, we're going to use Kubernetes. This has various benefits, which I'm going to discuss first, and then I will get into the code demonstration for today. In that demonstration, we're going to be creating our Kubernetes configuration files and setting that up on our local machines using the Kubernetes command line tool. And on the DigitalOcean side of things, we're going to be deploying to a Kubernetes cluster, and then we're going to stress test that. By the way, this isn't like some kind of run-of-the-mill, demo HTTP microservice. This is like an actual RAG application. So it's a little bit bulky. The dependencies end up making the Docker images pretty big. So that makes deploying this a little bit challenging, like you've seen in the previous videos. By the way, those previous videos are not a prerequisite for this, but if you like this video, you'll probably find those ones valuable as well. So I'll leave links to those at the end of this video and in the video description. If you're new here, hey, I'm Alex. On Zaz & Codes, my goal is to help make you a more well-rounded developer. I'm teaching full stack data science and sharing Zen lifestyle advice. If these topics are interesting to you, then I think you'll love my premium content on Patreon, and you can support me for zero cost by signing up for my weekly email newsletter. Here's 5 reasons to use Kubernetes for your microservice. The basic idea is replication. We have one microservice and we want to distribute the load of many users attempting to use that microservice. So that's the first reason. Kubernetes is a load balancer, and it provides internal communication channels between the instances of the microservice that are running. Isolation and fault tolerance. Imagine you had one server and you were running many instances of your microservice on that server, and perhaps you had some load balancer like Nginx set up on that server, which is just, sending your requests to those different processes. This isn't very fault tolerant, because if something happened to that one machine, all of those services go down. Kubernetes is different in this respect. Each instance of your microservice is deployed to an isolated container with Kubernetes. Automatic scaling. Kubernetes can be configured to automatically increase the number of nodes you have running, the number of instances of your microservice as you get more traffic, more load on your system. And then it can scale that back down when the load decreases. Rolling updates and canary releases. I talked about these canary releases recently in a video I made over on Patreon about the DevOps handbook. The idea with the canary release is a little bit morbid. When miners were working in coal mines, they would put like a canary into the coal mine, and if the bird died, they knew it was not safe for people to go in there. So taking that analogy into programming, if we have many different nodes running different instances of our microservice, we can just switch over to the new version like one node at a time and see how that does. And Kubernetes supports that deployment pattern. And so this is an example of how Kubernetes is powerful from a DevOps perspective and for CI/CD pipelines. And last thing before we get into the demonstration are some alternatives to Kubernetes. One is Docker Swarm, and then there's the cloud platforms, the big ones. So Google Cloud, Amazon, and Azure all have their own serverless offerings which function similar to Kubernetes. So for example, on the AWS side, there's Elastic Container Service. And on the Google Cloud side, there's Google Cloud Run. And these both have many, if not all of the benefits that I was just discussing without you needing to manage the underlying infrastructure of Kubernetes, which is no small thing. But on the other hand, they can be very expensive. Especially, I would say, as you're getting into the really high compute realm of things. That's where Kubernetes is going to be much more cost effective. So one recommendation might be to use a service like Cloud Run or Amazon's ECS. And then when that becomes a pain point for you because of the cost, then you might consider setting up your own infrastructure for Kubernetes. So with that introduction under our belts, let's get into the demonstration today. I'm pretty excited to launch this Kubernetes cluster and get our application running. So let's get it. Like I mentioned, we'll be deploying to a Kubernetes cluster on DigitalOcean. So I'm going to start by logging in here. If you don't have a DigitalOcean account, then I've left an affiliate link that you can use to sign up in the video description. And you'll get some free credits that you can use for today's demonstration if you want to follow along. So I'll log in here. Next, I'm going to show you the source code for the application that we're deploying today. Over in my Zazencode's YouTube repository, you can go to the source folder, and then there's one for RAG Microservice Python, and this is where we'll be working today. So you can clone this repository and head in here to see all the code. Over in my terminal, I've got this open, and I'm just going to open up Vim, and we're going to check it out. I just want to show you the very basics of how this works. This is the README file. So I have a run app.sh script, and after I run my app, I'll be able to talk to my microservice through HTTP. So you can send an HTTP request and you'll get back a response. And my run app.sh to run our application just builds the Docker image and then runs that. I'm going fast here because I've talked about all this stuff in length in my previous videos. So I'll just briefly show the Docker file. And this line here at the end is where we're launching our application, our server. It's a fast API application that I'm running with Unicorn. And that application is right in here in RAG Microservice app. And I have app equals, this is my fast API application object, and the two endpoints that we have access to are health and ask. So let me go back to my README to show you how these work. Here's an example of the health endpoint. It's just a simple GET request, and the ask endpoint takes a POST request. And this will actually incur cost. It's a RAG application that uses OpenAI's API in order to provide the language model aspect of the RAG system. The first step is to build this Docker application as an image on our local system. Then we're going to push that image up to DigitalOcean's container registry and reference that sort of hosted version of our Docker application with our Kubernetes cluster. Now I've got a Docker file here, but I have another Docker file called dockerfile.deploy. So if I look at the difference between this Docker file and that dockerfile.deploy, there's only one line different, and I'm copying my source code in rather than using a volume to mount that. What I'm talking about is right here. That's just for development, so I'll remove that for my deployment version. Now in any case, I've already built this image, so if I say docker image ls, I can see there's this one that's been tagged for DigitalOcean's registry. And in fact, I've already pushed this up to DigitalOcean's registry. Because I'm developing on Mac, but I wanted an image that would be able to run on Linux, Ubuntu, then I needed to do a lot of work for this. And so what I did was follow these guides here, where I used this docker build x. So this line, docker build x create use, it created this here. This is my Docker desktop app, and it created this build kit container, which is running. And using that container, I was able to use this buildx to build for a different platform. My platform is not an AMD 64 platform. If I just scroll up, my platform is this one here. It's an ARM 64. But I needed to build for a different system, so this was the method I used. But this took a long time. It took about a half an hour, and so I don't want to redo that. And then I ran this command here in order to push my build up into my DigitalOcean registry. And so I replaced this line here with my DigitalOcean registry line. I can show you some of these commands. If I just do a reverse search for build x, here's what I ran. And this is how I actually pushed to my registry on DigitalOcean. And again, I just want to stress, the reason I have to do this complicated build is because I'm developing on Mac, but I want to run my Docker image on Ubuntu. Say I was actually developing on a server that was Ubuntu, and I was going to build that for the same type of architecture that I'm building on, right? So you could pretend that this is a server, or maybe I've purchased a server and I'm just going to build on that, which, by the way, is a better idea than how I did things. In that case, all you would need to do is run this line right here, just to build on the local architecture of your computer. Let me actually do that to kind of show you. And instead of giving it the latest tag, I'm going to say Mac OS like that. So it's already ran. Now I can say docker image ls. Now I have an additional version here, which is tagged as Mac OS. And then if I wanted to push this one, what I would need to do is first log in with the DOCTL command line tool. So I need to make sure I'm logged in to my registry on DigitalOcean. And I'll talk about this DOCTL tool in a second. But after I've logged into that, what I would want to do is tag my image. So I could tag this image right here, and I would probably want to say like this, and then Mac OS. And then I want to tag that to here, Mac OS, like that. Let's try to actually run that. So Docker image ls, what do I have? So now I have that new tag, which is ready to put on the registry. It's like the same, see, it's the same image ID, but it's just a new tag for that image. It's like identifying the repository name. And now I'm ready to push this. So if I look for push, here's how I'd run that. And I just want to push this one for Mac OS. Let's actually go ahead and run this as well and see what happens. Here we go. So it's been pushed up, and let's hop over to DigitalOcean now, and we'll see this one that I pushed up as well as the previous ones, which are the ones I actually want to deploy, because this, I'm not going to be spinning up like a Mac OS Kubernetes cluster, of course, right? I'm going to be running that on a Linux system. So now let's go into DigitalOcean, and I'll first show you the container registry and these things that we've been doing in the terminal, how that translated onto DigitalOcean side of things. Then I will launch a Kubernetes cluster. Then we'll come back into the terminal and deploy to that Kubernetes cluster. I'll come down to the container registry, and you're going to see that I've set one up called Zazen codes right here, and this is the registry URL, which you just saw in the terminal that I was using. And I've used 3.5 gigs. If I open up my reg microservice, I have 4 images. This is my most recent one with Mac OS. I just pushed that a minute ago, which you just saw me do. And then in the previous video, I created this latest tag. So if I copy this one right here, that's going to be, let me show you. When I copy that, it gives me a URL that just looks like this. So this is going to be the one for Linux. And then the one I built today would be this one. And so this would be the one that I could use on Mac. So with the Linux one, I'm going to be very clear in this video. This is what we're going to use for Kubernetes. Now we're going to create our Kubernetes cluster from the DigitalOcean platform interface. I'm a big fan of DigitalOcean's interface. I find I have a really good experience here as a developer, but you can also use command line tools to do this. For now, I'm going to click Create and select Kubernetes. I'll start by selecting a data center region, and I'm going to pick Toronto. That's where I'm located. And scrolling down, I get prompted to select a version, and they're generally recommending the latest version. So that's what's selected here, and I will keep that selected. Next comes to the cluster capacities. This is the interesting section where you got to get your checkbook out. The default option is for $72 a month, but they charge by the second. So it's going to be 11 cents an hour. So for the purposes of this demonstration, I'm not really concerned with these options, but I will demonstrate to you if I was to pick like something, say I pick this memory optimized droplet, the cost skyrockets, and that's just for 3 nodes and a fixed size. So I'm not using auto scaling yet. And I could also select, so within the memory optimized, it's fixed in here, but let's go back to basic. And now I get some options of a node plan. So I could pick like 2 gigabytes total RAM, 1 vCPU, virtual CPU, but I'll just keep it on the default option so that we have less issues. I don't want any pain when it comes to like memory problems, but you would obviously want to pick only like as much as you need. Next, I'm going to name this. I'll call it Reg Microservice Pool. Now I'll scroll down, and I'm not going to select any of these additional options. Lastly, I'll give it a name. So I'm going to keep it in Toronto. I want to label that, and we'll do that. And then I'm going to say Reg Microservice, and I will click Create. I can see the progress of this spinning up. I'm going to sort of run through this getting started guide, and the guide is giving us instructions here to use this DOCTL command line tool. So I'm going to open this up, and this is the guide to installing it. I also have that open on a separate tab over here. So on Mac OS, I could use brew to install that. In the previous video, I installed that using this command right here, and using curl, and I'll show you where that is on my system. I'll hop back into my terminal, and it ended up in user local bin, and I'm going to grep for DOCTL. So, there's all the Docker stuff, but this one's it, DOCTL. Let me make that more clear. I'll just show you everything in here. And this is an executable in my path. So because it's there, I'm able to just go ahead and run this. And the other aspect of setting this DOCTL up is creating an API token and then setting that up on your system. So you would say doc auth init. I have this doc auth, DOCTL auth list. If I do that, I can see that I'm using something called YouTube temp that I created, just using this guide right here. And I'll show you my API key as well for that. I'm going to scroll down to the left. There's this little API on the sidebar. I'll open that up in a new tab. So the token I used was this YouTube temp. So if you haven't done this yet, you just do like generate token, and then down here I just said full access, generate token, and I use this to authenticate in my terminal. I'm just going to clean that up so that you guys don't have full access. And I'm also going to make sure to remove this because I revealed this to you in the last video. So by the time you're seeing this, this one will have been deleted as well. Let's hop back over to my microservice. I'm going to this is my Kubernetes cluster, and I'm going to refresh it and see how it's going. So I can see that it's online. All three of my nodes are running, and now I'm going to deploy my microservice into this Kubernetes cluster. Let's hop back to the command line, and I'm going to start running some commands in order to do this. If I type doctl Kubernetes, let's just see what I get out of that. And then I can say options or cluster. Let's say cluster. And now I could create, I could delete, I could get, retrieve details. I want to try and do that. So let's say get, and it's missing required arguments. So what I need is, I could say get, and then I need to pass the ID or the name. I'll hop back to DigitalOcean and let's try and get the ID or the name. Here's the ID. I'd rather use the name though. Let's try to just grab this as the name. And I'm going to actually define that. I'll say cluster name. And now with this command here, I want to get the cluster name. Right, so here it is. Now what I want to do is pull the configuration onto my local machine. So instead of saying cluster get, I'm going to say cluster kube config and then save. Adding cluster credentials to kube config file. All right, let's see what my kube config looks like. We can see that this has been configured. Like this is that URL, which was just shown in my terminal. If I get out of this, that URL was up here. That's the one that I got printed out when I asked for information about my service. Now I'm going to run a command with the Kubernetes command line interface. And so Kubernetes has some installation instructions here. I've already gone ahead and installed that, but you could go ahead and download the binaries for your system or just look up installation instructions for kube command line interface for your system. And once you have that, you'll have access to something called kubectl. For me, this is in my user local bin, and it's right there. So let's say kubectl, and I'm going to say get nodes. So here's the 3 nodes, which I've just set up. So what I'm going to do is I'm going to create a deployment and a service YAML, and then we're going to configure kubectl. We're going to apply those to our Kubernetes configuration, and we're going to try and deploy. Hey guys, just a quick interruption from the sponsor of today's video, which is myself. So you can head over to Patreon in order to help support the work I do. And I want to provide you with something valuable there in return for your support. So I'm creating book notes. I like to read books on machine learning and data engineering and development. And so I create notes, which are slides, and then I walk through those slides. These are like video walkthroughs, but the idea with these notes is that you could like plug them in and listen to them like they're a podcast as well. And going forward with this channel, my goals are to help make you a more well-rounded developer by teaching full stack data science and also sharing my Zen lifestyle advice. So I read a lot of books on productivity or Zen philosophy, and so I want to start making book notes and sharing my ideas around those books as well. So that's the future of the channel. That's kind of the community that I'm envisioning building here. You can head over to my Patreon, and you can even join as a free supporter over there. And another great zero-cost way to support the channel is by signing up for my free weekly email newsletter. Thanks so much, and let's get back to Kubernetes and the hell that we're in with today's video. So I'll start by creating this deployment.yaml, and I have some code like a template that I'm gonna just paste in here, and we're gonna edit that. And I'm gonna do the same for service.yaml, and I have some code as well for that. Now let's open these things up, and I have Vim open above, so we'll just go over there. And by the way, I want to show you a Vim thing. So BD, so if I say fs and I want .yaml, these are all my YAML files. So I can do a Control Q to put this into a quick fix list, and then I say cdo edit. and that'll open up my entire quick fix list, which is pretty sweet. I'll get out of that one. And now deployment, let's focus on that one first. I was provided this from ChatGPT. I want to replace this with the image that I have hosted on DigitalOcean. Copy the latest tag. This is the one that's that I've built for Linux. So let's paste that in here. And the port is 8000, not 80. Let's give this one a shot and then go to service. And I'm gonna keep most of this the same, but the port again is gonna be 8000 because that's where my API is running. Let me just show you that. If I look at my Docker file, look at how I'm running it on port 8000. Now let's try and go ahead and deploy this. kubectl apply f deployment. And it's been created. And next I want to do the same, but for service. And that's been created as well. So if I say kubectl get deployments, I can see that 0 of 3 are ready. Let's try kubectl get services. All right, a few things. The first one, in my service.yaml, I want to end on port 80. So even though the target port inside of the Docker image is 8000, I want to be able to hit my service on port 80. And then it'll like do that mapping to port 8000. So I want to do that, and then I want to service. I want to reapply my service. That's the first thing. The next thing is I'm getting an error right here. Failed to pull registry DigitalOcean.com. So I'm going to go over to the DigitalOcean side and make sure that my container registry is properly configured to talk with Kubernetes. Let's try that over here, and I'll go to container registry, and over in the settings area, DigitalOcean Kubernetes integration. It'll add a secret to namespaces of chosen Kubernetes clusters. And that's like exactly what we want to do. So I'm going to click edit, and I'll grab this one, and I'm going to click save. Now let's go back to my terminal and somehow try this again. So if I get my deployments, I'm going to use this name, and I'm going to restart it. So I'm going to say kubectl rollout. If I just enter that, it's going to give me some options. So I can do this one. So I could look at the status of it, and then I could restart it. That's what I want to try and do. So let's go and try and find this status, first of all. It doesn't have a resource type, so status, and it was deployment. It's a resource type of deployment. It's exceeded progress deadline. It's not happy. Let's restart it. So instead of status, I'm going to say restart. Okay, it's been restarted. Look at my pods again. So I can describe that pod like this. A kubectl describe pod. Let's look at the container creating one. Successfully assigned pulling image. So we have an update here. Let's see if I can get some logs from this pod. I'm going to go back to get pods, and then I'll type, okay, crash loop back off. So it's detected that it keeps crashing and it stopped trying. So kubectl, and I'll say logs, and let's get the logs from, I don't know, one of these first. Aha. So my OpenAPI API key variable is not set. That's actually really great news. It means it's like running my Docker image, but I just never dealt with this environment variable. So I need to pass that somehow into my service in a secured way. This variable was in my env file. So when I say run app, I'm passing this env variable like this, but I never did anything about that for Kubernetes. So I'm going to need to make sure I set that for my deployment. At this point, the other thing I need to make sure I'm doing is making my data available so that I have the data volume, which I need for my RAG system. So let's do both of those two things. So let's update everything below this template line. And I'm going to come down here and paste some new code in here. This is all looking pretty good, but check this section out. Now I have this from environment, and I'm going to have to create this secret, and I'm going to show you how to do that in a second. It's going to store that on my local machine and load it in here in a safe way. And then for volume mounts, I want to load a mount path. I want to load this data directory. So we'll see how that works in a second as well. I just need to add one more line here. So instead of this, I want to then reference this volume. So under spec now, I have containers, and I have like some container information in this YAML file, and then I have some volumes information down here. So I'm referencing my data volume, and here I need to have the path on my machine. So for me, it's users Alex, and then let's come down here. The data is right in this folder. So I'm just going to grab this path, and we're going to paste that in here. And now it's in data. Let's see if that works. It's a directory. Now I need to create this secret right here. So I'll show you how to do that. I'll do kubectl create secret generic. Grab that, come down here, paste that in here, and now I want to say from, and I go like this. I say from env file and .env. I have this .env file available local right in this folder here. All right, it's been created, and just to prove that, I'll just say this is that file I'm referring to, this .env. So this secret now should be loaded up from that .env file. I'll apply my deployment, and now I'm going to restart it. So it was rollout, restart deployment. So let's run that as well. Let's get our pods. So it's in container creating mode. I could say kubectl describe pod, and let's have a look at one of these ones that's creating. We'll see how it's going. It's mad at me. It says data volume, host path, type check failed. This is not a directory. I'm going to try replacing directory with directory or create. I was reading online, that might help. Let's redo our deployments and then rollout, restart. Looks like I have a pod that's running. Okay, so I recognize this error. We're making progress. We're loading documents for reg, so it started my server, but this volume is not working. And I know the volume's not working because I recognize this error. It's trying to get some file that doesn't exist. So all we got to do is get this volume working, and we're going to be good to go with our application. Okay, so I have tried many painstaking ways of mounting this volume, and I've given up. I'm going to get rid of all my volume mounts. My secret's working, which is cool, and I'm going to go with a different approach. And what I'm going to do, just for the purposes of getting this up and running, is to bake this data directly into my Docker image. So I have a Docker file called dockerfile.deploy. I'm going to make a copy of that, and I'm going to call it dockerfile.k8deploy. I'll open that one up, and now where I'm copying my RAG microservice, I also want to copy my data over. So I'm just going to copy the data into the data, just like that. And now I'm going to rebuild this and push it. So I had build X. So this is cool. I'm going to call it K8 as the tag for this one, and I'm going to call it K8 deploy. So this should build and push my Docker image to my DigitalOcean container registry. And it's probably going to take about 15 minutes. So I'll see you on the other side. All right, this is exciting. This last command took 25 minutes to run. I built my new image, and I copied the data inside of the image, and then I deployed that, or I pushed it to the container registry on DigitalOcean. And looking at my container registry, I've exceeded my limit for my plan, but that's cool. It didn't error out because it's just going to charge me for that overage. No problemo. So here's my repositories, and this is the new one that I've got. It's this K8s tag, and so I'm going to update my deployment information with Kubernetes to use this one. Let's go up here and go to my deployment YAML. And instead of using this latest tag, I'm going to use the new Kubernetes tag. So I can go back, delete that, and paste that in. So it's the same URL, but now I have this K8s at the end instead of latest. And the purpose of doing this is to bake my data right into my application so I don't have to worry about these volumes. And I think that's all let me go to my service. Yeah, I don't reference it there. I think this is the only time when I reference this image. So I'm good to go, and I'll remind you, by the way, if you're doing this, make sure you have this enabled in your settings, this integration, because otherwise you won't be able to pull from this container registry. Right, so let's give this a go. I'm gonna say kube, we're gonna apply. So I'm gonna apply my deployment, and then I'm gonna say kubectl and rollout, and we're gonna restart the deployment. Now I'm gonna say kubectl get pods, and these guys are in the crash backoff from a long time ago, but these ones are recent. So this was before I updated my Docker file, but these recent ones are creating. Let's keep an eye on this. These are still container creating. Let's look at some logs from these ones. The logs say it's just waiting to start. Describe pod. And right now it's working on pulling this image. So because it's so big, this might take a little bit. So I was able to pull it, and it started our RAG microservice. Let's see if I can get those logs now. Oh, I cannot express to you how painful it has been to try and work with Kubernetes. And I think I just got it working. So I want to hit my load balancer now and see if I can talk to this. Maybe what I want to do is get my services. Okay, this is what I want. Here's my load balancer. And I've got an external IP address. Yeah, I'm going to curl it with HTTP. And then I'm going to check the health. Yep. Oh, hell yeah. Okay, it's healthy. This is incredible. Let's hit it. Let's hit it. Let's hit it. Let's do ask. I'm going to do my ask endpoint. In fact, I'm going up to my README here. All right, so server IP now is going to be this endpoint right here. So we're going to say server IP. That's my load balancer endpoint, which I just grabbed from right here. I'm going to hit that load balancer to use my Kubernetes service. We're going to ask a question. I'm going to come in here. I'm going to delete this. I need a good question. Tell me about my fave character, Mr. Nimbus. So this is going to send this off, and it's going to get allocated to one of my pods. All right, while that's running, let me have a look at my pods and see what they're doing. So kubectl get pods. These are my 3 pods. They're running. So one of these pods is dealing with this request right now. Let's check out some logs. So kubectl logs, and I'm going to look at my logs for all of my pods. I'll start with the first one. So it hasn't picked up this request. Let me try my other the logs for my other pods. So I'll try my second pod. This one dealt with my health check. So that got served my health check request. And let's check out the third pod. This is the one that I expect I'll see some logs from dealing with my request right here. Uh-oh, so I failed to connect. What's going on with that? I know what's going on with that. I tried to get the port 8000. That's not what I want to do. This is not running on port 8000. It's running on port 80. It's just the default HTTP. So this is what I need to do. All right, let's try that. And now I'm going to check these logs again. Look at this. Look at this. This, I don't know what this is. This is doing a 400 error for some reason, but I did get a response back. So somebody picked this up. Let's try and figure out which pod returned this response for me. And by the way, Mr. Nimbus is season 5, episode 1. Great episode. Now what can I do? I can say kube. Let's list my pods again, and I'm going to check out each of these. So I'll grab the first one. And we're going to say kubectl logs and check that one out. That one definitely didn't pick it up. There's no logging. This one has done no work so far. I'll check the second one. Here it is. This is the one that picked up my request. Yes, I'm honestly like beyond psyched right now. Now let's stress test this thing. And I'm just going to hit my health endpoint, and I'm going to try and blow this thing up. So in order to do that, I'm going to install something called Hey. Let me actually go to like a brand new area to do this in. I'm going to brew install this Hey tool. Let me show you what that's all about. So the purpose of this is to send a big load to a web application. And I can do it with through the command line. So I'm just going to send a crap ton of requests over here. This has installed, so if I just type hey, get some information on using this, so we're good to go. So here's what I'm going to do. I'm going to use this Z flag, duration of application to send requests. So I'm going to do it for I don't know, like a minute. Or yeah, let's try it for a minute. And then there's a C flag, number of workers to run concurrently. The default is 50. I'll just leave that to the default. And then for Q, where's the Q parameter? This one, rate limit, queries per second. The default is no rate limit. I'm going to set a rate limit for this. So I'll say hey and Z, and this is going to be 1 minute. And then I'm going to say Q, and we're going to do it for how many requests per second. Let's do like 1 request per second, just to like check this out. And I'm going to hit HTTP, and then what did I call my, what was my IP address? kubectl get services, and it was inside of here is my external IP on my load balancer. So I'm going to pop that in right like this. What else am I doing? I want to do the health endpoint. That's the one that I'm going to like spam, and we're going to try and monitor a response from our Kubernetes cluster. Let's run that. I can't really tell what the heck is going on. Let's see if I can get some information. kubectl get pods. Check that out. When I say kubectl, I'm getting some information in my terminal here about which service I'm connected to. That's pretty cool. So I can get some pod stuff. So this finished up, and this is pretty cool. It gave me some metrics on like my response time from my application, the number of requests per second. Right. So even though I'm only sending one, these are happening concurrently over 50 like nodes. So I'm sending actually 50 a second. That's very cool. And I love this response time histogram. Like, it's super cool. So this time I'm only going to run it for 10 seconds, but now I'm going to take this concurrency flag away. I'm going to let it send as many as it can, and I'm going to send it from 200 concurrent nodes. So this is going to be a much more intense stress test. And yeah, let's see how everything goes. So I'll run that. While that's running, I'm going to look at my pods, and I'm just going to watch them to see if they die. It says they're all running, no restarts, but since I have the watch flag, it should, okay, here we go. So it already finished. Here's my response time distribution. The server is having no problem with this. You know, I would need to create something a little more intense than just a simple health check endpoint in order to really stress test this well. Let's have a look at some of these logs then. Lots of logs for all of these requests that it's serving. But again, just no problem whatsoever dealing with these things. Of course, the real way to stress test my application would be to instead hit the ask endpoint. But like I mentioned earlier, this one would use a lot of my tokens. This would cost me a lot of money, this type of stress test. So let's see, when I said, hey, instead of doing health, what I would want to do is ask. But this is going to use my OpenAI API credits, not an option. Like, it'd be very expensive to do. So when I ran this stress test like this one, I'm hitting the health endpoint, which clearly is way too easy for my server. I would want to hit something a little stronger to properly stress test this, and that could be the ask endpoint. That would be really interesting. However, each time I make a request to that endpoint here, I'm making an OpenAI API request, which costs me money. So it's not an option to do a stress test on this endpoint. What I would want to do is have an endpoint like this, maybe test/ask, and then that would be like a mock testing environment where I don't actually make API calls, but I do some sort of computation that's equivalent in terms of usage on my server. That would be a really cool one to stress test. So if you want to see this mock test on my RAG application or something else with Kubernetes, let me know in the comments below, and I can make a video on that for you. But for today, we're just going to spin all of this stuff down, and I'm going to focus on taking everything off of DigitalOcean because that's where we're incurring all of our cost. So the first thing I would want to do is bring down my Kubernetes cluster. I can simply go to the Kubernetes section, grab these little dots, and just say destroy. And I'll select all of my load balancers. I'll click, copy the name, paste it in here, and I'll destroy this cluster. I'm going to keep mine up for now, so I won't actually do that. But the other resource we used is the container registry. So you can hop over there, and what you could do is clean up this image. You could right click here or click on these little dots and click delete, and go ahead and delete this. Once you've deleted that, you can go over to settings, and you can edit your plan and just drop down to the starter plan. That way you can keep your container registry name for free. And that's all I have for the demonstration today. If you're still with me, I'd appreciate it if you give me a like and consider subscribing if you want to see more videos like this. If you want to see easier ways of deploying a Docker image, I'll link a few videos at the end of this one, which I described in the introduction to this video. And I'll also post that video that talks more about how the RAG microservice itself works with the Haystack library and with our fast API server, where I walk through all of that code in detail. Let me summarize everything we did because it feels like there was a lot going on. We had a Docker image, which was a RAG microservice, that's retrieval augmented generation. And how this works for us is we take an API or an HTTP request with some question, and then we serve back a response. And in the middle there is when we ask OpenAI, we make a request to that for data, providing the context of some documents that we have, and then we serve that response back. That's how our microservice works. Now, we wanted to get this running on Kubernetes so we can distribute it. And as you saw, we had a load balancer, and it was like pointing traffic to one of 3 nodes that we had all running this same microservice. But we ran into a few complications. And the first complication was I'm developing on Mac OS and I want to deploy to Ubuntu. So I needed to jump through a few hoops in order to build on a Mac OS a Docker application that will run on Ubuntu. So I had to use a special way of building that with Docker. The second hoop that I had to jump through is sharing my .env file and my volumes with Kubernetes. The .env file was pretty straightforward. We pushed through that easily, but the volume was detrimentally difficult. I wasn't able to get the volume working in an analogous way to how I use Docker volumes. So what I ended up doing is baking our RAG data directly into the Docker image. This obviously isn't scalable for like a large data set. You'd have to do something more advanced with Kubernetes, which would be a great topic for a future video. But within the scope of today's video, that just didn't fit. So like I said, my solution was to just bake that data directly into the Docker image. That way, when I pull that into my Kubernetes nodes, the data is available on those nodes for my RAG pipeline. And another thing that we had to dance around was the container registry. So we're using Kubernetes on DigitalOcean, and we're also using the DigitalOcean container registry to push our Docker images to. We have our local system, which is kind of the brain of the operation. And then it's utilizing the cloud services from DigitalOcean. So the brain builds the Docker image and then sends it off to the container registry. And so the brain, your local computer, also is like configuring the Kubernetes deployment and submitting that. And so this brain has to, you're not actually running Kubernetes on your computer. We've provisioned infrastructure for that on DigitalOcean. So on the DigitalOcean side of things, we need to configure our container registry, and we need to configure a set of pods for Kubernetes in order to deploy this. And that comes with a load balancer. And that load balancer is what we end up talking to. We're just hitting that load balancer endpoint, and the load balancer then sends off the traffic to Kubernetes. Thanks a lot for watching this far, and namaste.